Leviton Decora home control devices are generally considered reliable and well-made. They use a proprietary Zigbee mesh network, which provides a robust and stable connection. The devices have a built-in surge protection to prevent damage from electrical spikes. DHC devices operate on the 2.4 GHz frequency band, which can be subject to interference from other wireless devices and appliances. In general, interference is minimal, especially if there are not a large number of other Zigbee or Wi-Fi devices in the vicinity. To minimize interference, it's recommended to position the devices away from potential sources of electromagnetic noise such as microwaves and cordless phones. DHC devices are relatively easy to set up and use. They come with a user-friendly app that allows control of the devices remotely and to create schedules. The app also provides troubleshooting tools to help resolve any issues that may arise. Overall, Leviton DHC is a reliable and user-friendly home automation system that is well suited for simple automation setups in residential homes. While interference can potentially occur, it is generally minimal and can be mitigated with proper installation and device placement. The DHC system can support up to 50 devices per gateway. If the automation setup requires more devices, consider using a different system or adding an additional gateway. DHC devices are only compatible with other Leviton DHC products. They cannot be integrated with other home automation systems or devices outside of the DHC ecosystem. DHC devices can be more expensive than some other home automation products. Consider the cost-benefit ratio before making a decision. When considering a simple automation setup in spec homes, reliability is paramount. A system that minimizes headaches after move-in is crucial for maintaining a good reputation. Leviton Decora home control devices offer a potentially viable solution. The Zigbee mesh network employed by DHC contributes significantly to its reliability. Mesh networks are designed to provide redundancy and resilience. If one device fails or experiences interference, the network can automatically route communication through alternative paths, ensuring continued operation. This is a key advantage over star or hub-and-spoke network topologies, where a central point of failure can disrupt the entire system. The built-in surge protection is another important feature for reliability. Electrical spikes and surges are common occurrences in residential environments and can damage sensitive electronic equipment. Surge protection helps to mitigate this risk, extending the lifespan of the DHC devices and reducing the likelihood of costly repairs or replacements. While DHC devices operate on the 2.4 GHz frequency band, which is also used by Wi-Fi and other wireless devices, the potential for interference can be managed effectively. Firstly, careful placement of devices away from potential sources of electromagnetic noise such as microwaves and cordless phones can minimize interference. Secondly, limiting the number of other Zigbee or Wi-Fi devices in close proximity to the DHC network can also help. Thirdly, the Zigbee protocol itself incorporates mechanisms to mitigate interference such as frequency hopping, where devices automatically switch to less congested channels. Ease of setup and use is another important consideration for spec homes. A complex and difficult-to-use system is likely to generate support requests and dissatisfaction among residents. The user-friendly app provided with DHC devices simplifies the setup process and allows residents to easily control and manage their home automation system. The ability to create schedules is particularly useful for automating tasks such as lighting and temperature control, enhancing convenience and energy efficiency. The troubleshooting tools included in the app can also help residents resolve minor issues themselves, reducing the need for professional assistance. The DHC system's limitation of 50 devices per gateway is a factor to consider, especially for larger homes or those with extensive automation needs. If more than 50 devices are required, alternative systems or the addition of an additional gateway would be necessary. The compatibility restriction of DHC devices to the Leviton DHC ecosystem is another important consideration. This means that DHC devices cannot be integrated with other home automation systems or devices, which may limit flexibility and choice. However, if the goal is to create a simple and self-contained automation system within the Leviton ecosystem, this may not be a significant drawback. The cost of DHC devices is a final factor to consider. DHC devices tend to be more expensive than some other home automation products. A careful cost-benefit analysis is necessary to determine whether the features and benefits of DHC justify the higher price point. Factors to consider in this analysis include the reliability of the system, the ease of setup and use, the level of integration required, and the long-term cost of ownership. In summary, Leviton DHC offers a potentially reliable and user-friendly solution for simple automation setups in spec homes. The Zigbee mesh network, built-in surge protection, and user-friendly app contribute to its reliability and ease of use. While interference and compatibility limitations should be considered, these can be managed effectively with proper installation and device placement. Careful cost-benefit analysis is necessary to determine whether DHC is the right choice for a particular project. Let's delve deeper into some specific technical aspects to provide a more comprehensive understanding of the Leviton DHC system. The Zigbee protocol, which forms the foundation of the DHC network, is based on the IEEE 802.15.4 standard. This standard defines the physical and media access control layers for low-rate wireless personal area networks. Zigbee builds upon this foundation to provide a complete networking layer, application layer, and security framework. One of the key features of Zigbee is its support for mesh networking. In a mesh network, devices can communicate directly with each other as well as through intermediate devices. This creates multiple paths for data to travel, enhancing reliability and resilience. If one device fails or experiences interference, the network can automatically reroute communication through alternative paths. Zigbee also supports different network topologies, including star, tree, and cluster tree networks. The choice of topology depends on the specific application requirements and the characteristics of the environment. The 2.4 GHz frequency band used by DHC is a globally recognized band that is also used by Wi-Fi, Bluetooth, and other wireless devices. This can lead to potential interference, but Zigbee incorporates several mechanisms to mitigate this risk. Firstly, Zigbee uses direct sequence spread spectrum modulation, which spreads the signal over a wider frequency range, making it more resistant to interference. Secondly, Zigbee uses channel hopping, where devices automatically switch to less congested channels. Thirdly, Zigbee uses collision avoidance techniques to prevent devices from transmitting simultaneously and interfering with each other. The DHC system's support for up to 50 devices per gateway is a limitation to consider. A Zigbee network can theoretically support thousands of devices, but the practical limit is often determined by the processing power and memory capacity of the gateway or coordinator device. The gateway is responsible for managing the network, routing data, and providing access to the Internet. The compatibility restriction of DHC devices to the Leviton DHC ecosystem is a significant factor to consider. This means that DHC devices cannot be integrated with other home automation systems or devices that use different protocols, such as Z-Wave, Wi-Fi, or Bluetooth. This can limit flexibility and choice, as well as the ability to create a truly integrated smart home ecosystem. However, if the goal is to create a simple and self-contained automation system within the Leviton ecosystem, this may not be a significant drawback. Leviton offers a range of DHC devices, including dimmers, switches, outlets, and sensors. These devices can be controlled remotely using the DHC app, which is available for both iOS and Android devices. The app allows users to create schedules, set scenes, and monitor the status of their devices. The DHC app also provides troubleshooting tools to help users resolve minor issues themselves. These tools can include diagnostics, error messages, and step-by-step instructions. The cost of DHC devices is a final factor to consider. DHC devices tend to be more expensive than some other home automation products. This is partly due to the higher quality components and the more sophisticated technology used in DHC devices. However, the higher price point may be a deterrent for some users. When comparing DHC to other home automation systems, it's important to consider the specific requirements of the project. DHC is a good choice for simple automation setups in residential homes, where reliability and ease of use are paramount. However, for more complex projects or those that require integration with other systems, other options may be more suitable. For example, Z-Wave is a popular protocol for home automation that offers a wide range of compatible devices from different manufacturers. Wi-Fi is another option, but it can be more susceptible to interference and security vulnerabilities. Ultimately, the best choice depends on the specific needs and priorities of the user. When installing DHC devices, it's important to follow the manufacturer's instructions carefully. This will help to ensure that the devices are installed correctly and that they function properly. It's also important to choose a location for the gateway that is centrally located and away from potential sources of interference. The gateway should be connected to the internet via wired Ethernet connection for optimal performance. When setting up the DHC network, it's important to choose a strong password and to enable security features such as encryption. This will help to protect the network from unauthorized access and to prevent data breaches. It's also important to keep the firmware of the DHC devices up to date. Firmware updates often include bug fixes, security patches, and performance improvements. Keeping the firmware up to date will help to ensure that the DHC system is functioning optimally and that it is protected from known vulnerabilities. In addition to the technical aspects, it's also important to consider the aesthetic aspects of the DHC devices. DHC devices are available in a range of colors and styles to match the decor of the home. It's important to choose devices that are both functional and visually appealing. DHC devices are also designed to be energy efficient. They use low-power radio technology to minimize energy consumption. This can help to reduce energy bills and to minimize the environmental impact of the home automation system. DHC devices are also designed to be durable and long-lasting. They are made from high-quality materials and are tested to withstand harsh environmental conditions. This helps to ensure that the DHC system will provide reliable performance for many years to come. In conclusion, Leviton DHC offers a potentially reliable, user-friendly, and aesthetically pleasing solution for simple automation setups in residential homes. The Zigbee mesh network, built-in surge protection, user-friendly app, and energy-efficient design contribute to its overall value. While interference, compatibility limitations, and cost should be considered, these can be managed effectively with proper installation, device placement, and a careful cost-benefit analysis.